Hello everyone. In this session, we discuss about distributed representations in neural networks. So, in distributed representations, a neural network learns about the features of the data through the concepts and inputs, which are represented as a pattern of activity across many units of neuron. So, in this kind of representation, each neuron will participate in representing many different concepts. Before this distributed representations, we used to have local representations. Let us see one example where localist representation is done. Now, suppose there are four shapes: vertical rectangle, horizontal rectangle, vertical ellipse, horizontal ellipse. Now, if we employ a neural network to learn these features, I used four neurons. Each neuron is only storing a specific information about this feature of this object. Suppose in first neuron is holding the information of vertical rectangle, second neuron say this one, third neuron vertical ellipse, fourth neuron horizontal ellipse. This kind of representation in neurons means they are only localist representation, means you don't have any scope for representing more concepts in this kind of representation. In distributed representation, what we do, along with these features, I also store the concept about this shape. Like here there are four things like vertical, horizontal, rectangle and ellipse. Now these neurons not only stores it as a vertical information, but it also stores the information as a rectangle. So here the two concepts can be stored in this kind of representation. Here only one data item is represented. Here a neuron is able to store multiple features and concepts. So when it is activated, a group of neurons are activated together, so that we can improve our efficiency of our network. Means it is storing more knowledge than normal localized representation. So refer to the here this distributed representation refer to the encoding of information across multiple neurons than just a single neuron. Means here this information about this rectangle, earlier we stored in only one neuron, but here I am storing this information in two neurons, one neuron holding about its shape, another holding about its position, whether vertical or horizontal. So this way multiple neurons rather than just a single neuron for concept or entity. Now, what are the advantages, key aspects when we store features in multiple neurons in distributed representation? So first activation patterns. In a normal localized representation, only one single neuron is activated, but in this kind of representation, multiple neurons are get activated for a pattern of activation is you can expect from the neural network. Second one, shared units. Shared units, each neuron contributes to the representation multiple means each neuron represents multiple concepts, and multiple neurons represent the each concept, so that if there is any damage to one neuron, it won't affect to the entire processing of other neurons. Means if a information is lost in at least one neuron, we can get that information in another neuron through some kind of a concept. So that is the advantage of using a shared units. In a previous localized representation, if any neuron is damaged, suppose one neuron is damaged, that is representing this vertical ellipse. So the entire learning wise this feature is lost, means our prediction of outputs also will affect the this missing ellipse. So here if at least if this neuron is lost, at least somewhere the information about is stored in some other neuron that will get activated. So from that we can generalize other concept. So third feature of this distributed representation, semantic similarity. So entities sharing similar characteristics or semantic relationship tend to have vector representation that are closer together in a high dimensional space. Means sometimes if we concepts wise some concept they look similarity, say we can use the if that say similar nature of concepts can be grouped together in this kind of semantic similarity. So generalization, we can see unseen data in the features when they are distributed across multiple people, means multiple neurons. Suppose a single neuron is holding a concept, we may not see any unseen data, but when it is distributed across multiple neurons, a new kind of a data can be seen. That is one advantage of using distributed representation. So these 4 activation patterns, they are done as a group wise. Each neuron share multiple concepts. So all concepts of similarity, they are grouped together. Generalization, you can get the unseen data from the features. So how it is done? In localized representation, you see, in one-hot encoding, what we do in natural language processing, we apply this distributed representation in many applications. Like in one-hot encoding, each word we give assign as 1, means there are many neurons. Only one particular neuron is storing information about this word. This is a representation in localized representation. But in distributed representation, word members, they have given 4 ways of measurements, like animal, domesticated, pet and fluffy. So if a dog is there, it is storing concept about how much it relate to that animal, how much it related to domesticated, petty, means here only information about whether dog exists or not is stored here, but here each feature of dog is stored, and it is distributed across multiple neurons. That is one advantage of having distributed representations. So advantage 1, robustness. Damage to a small number of neurons is less likely to disrupt the overall representation. If some neurons also missing, it doesn't affect the entire overall output of that entire model. Generalization, I already covered this. So ability to capture complex data, complex relationships. Sometimes normal representation may not show complicated relationship among the features that can be represented in distributed representations. Let's have one application, word2vec. How they use this representation, a most popular word2vec, where we guess we generalize new things from existing data. So they represent data in this word2vec as like a bag of words are there. Horizontally they are words that are that come under for our context, and these words are from the Therosis, their dictionaries. We give one measurement for each word with that word. Suppose authority is there. How much authority word is related to battle, horse, king, man, queen. We give some degree of membership type values. So king has 1, whereas man has 0.2, queen has 1. Like this for every word in our context, like in our bag of words, how they are related to our context. You can give values like this in a distributed representation. And when a model wants to predict something, like suppose model is saying that some inherent data is there. Suppose I have a king is one word, king man plus woman. So when these two words are combined together, we can infer that this should be some queen, means only generally a woman is associated with this king man or queens. So we are human beings, we can directly we can get this inference that she is a queen. But our neural network model, what it do, this data distributed representation, it takes the values of king as they are related to other words with their values 1 0 0 1 minus 1. It takes the values of man in the network 0 and women. When you combinedly add together, they are most similarity, they matches with the queen data. So indirectly we can conclude that king man plus woman is nothing but a queen. This kind of a logic we can apply in neural networks when we show the data in the form of a distributed representation. See, suppose there is a natural language processing, there is a sentence given like a small story is given like this. My model is trying to learn the words from this one. So it after this it forms a new rules. Suppose there is a ordered and is, it may means a king may order. These two words may imply king, means king follows from ordered and is, or emperor follows from ordered and is. Indirectly we can conclude that king is emperor. How it is possible? My neural network first takes a bag of words of each of this paragraph into some neurons. After distributed representation of ordered, how much each word is related to this order 0 0 0 order 1, these are calculated. In first layer, this input layer is sent to hidden layer as our regular feed forward network. This network tries to learn, and finally it gives the output as king 0.02. As our regular how it works means here this loss is calculated whether really this ordered plus this sample is really generating king or not. If any error is there, again that is back propagated into the network. A gradient descent is applied, weights are readjusted, and again network learns with the new values of this relationship. Like means here concepts can be represented in this kind of a distributed representation along with the neural network models. So this way we can use distributed representation. Thank you.